Hey everyone, this is Ashwin here. In this video, we are going to see about toxic comment classification. So this is a multi-label classifications. That's why I chose this specific data set, because so far we didn't touch on multi-label classification, which is completely different from binary classification and multi-class classification. So in this given Wikipedia comment, we just have to classify all these labels. So we have like a large number of comments that is labeled by human raters. So each comment can have multiple labels or no labels at all. So all these are like toxic or negative comments is just labeling what type of negative comment that is. So toxic, severe toxic, like that we have 6 different labels. So either a command can have no labels at all, or it can have a single label, or it can have more than one label. So that's why I chose this specific data set in order to show you how you can do this multi-label classification. And similar to this, you can also use Cora dataset, where you can label the tags of a specific question, like if a particular question is related to tech and medical related, means it can have both medicine and technology, something like that we can tag it. So that's how this specific use case will help you whenever there is a need of tagging, where there is like multiple labels can be there for a single input. You can use this framework. Okay, without further delay, we can dive into the project tutorial. First, let us import the modules. So I'll just import all the basic modules that is needed for all the projects quickly. I think by now you guys have adjusted to all these basic modules from previous projects. So visualization, we will use both Seaborn and Matplotlib. And we also use NLTK for processing. I'm not going to touch into deep learning. This is a beginner tutorial. So for better results, it's always better to go with some neural network for the language models, as so many advanced models came recently. And let's also use stemmer. Not sure why okay, it's working. I thought the suggestions were not working. So this is a single base part, and other than this, we also need to import scikit-learn modules. So from scikit-learn.model selection, import train test split, and from scikit-learn.feature extraction, and there are multiple feature extraction module. So text, import tf-idf vectorizer, and we will also use pipeline, which we've seen in the recent videos, so that we can minimize our work. Pipeline, and this is the different module which you would not see in like other projects, which is sklearn.multiclass, import one versus rest classifier. So this is the multi-label classification use case. This is from. Okay, one versus one and one versus rest. So under this one versus rest classifier, we will also initialize another model, which is like a logistic regression, random forest, naive bias, etc. So that's how the multi-label classification works. And scikit-learn dot linear model, I will import logistic regression from scikit-learn dot naive bias multinomial NB, and other scores also we can get it. I will use classification report, but we will also need ROC AUC scores. So I'll just import everything for now. ROC AUC accuracy score, okay, and ROC curve classification report. Okay, these are other scikit-learn related models, which is building the model pipeline. And lastly, we will just import warnings, filter warnings, ignore. I think we should import this warnings at the first, so it will avoid this warning itself. Okay, now import of modules are done. Let's load the dataset. I will give the dataset description. I will give the dataset link in the description, or you can also get it from my GitHub repo. So dataset will be df equals pd.readcsv train.csv. I'm not going to use test, as this is a tutorial. If it's a competition or some use case, means you can also use the test dataset. Okay, now you can see we have ID, comment text, and all these are the labels. We can just see it's one hot encoding, so it either have a 0 or 1, and you can clearly see most of them having like 0. It means it's not like a negative comment at all. We will also do some exploratory data analysis to see how many comments have no labels, or one label, or more than one label. So we will see that soon. And df.describe. So this is a basic analysis that we can do. So based on this, I don't think we have pretty much all the values. Sorry, this is dataset description, and we need some, sorry, dataset stats, and we need dataset info, which is df.info. Here we can see only ID and comment is object, and all the others are like integer, so it will have like 0 or 1. They can also have like boolean instead of like int64, so it will occupy less space. Then we will do the data preprocessing and EDA. So I think we will go with data preprocessing. So check for null values. df dot is null dot sum. So as you can see, there are no null values, so it will save a lot of time for us. Let's also see how many values are there, or how many samples are there in the dataset. We have around 1,59,000 samples in the dataset. So this is a reasonably big dataset. That's why I just used logistic regression or naive Bayes. If you use random forest, means it will take a lot of time to do the training. Let's do the preliminary analysis. I will just go into the exploratory data analysis. So here we will see how many articles are there, how many articles are having without labels, and how many having like total labels. So x equals df dot iloc of. So this means we are taking all the rows, but we just need from 2. We just only need the labels, right? So 2 colon. We will ignore the ID and the comment text here. We are just only taking the labels and store it in X. I'm just taking a sum of those. If you display this, it will just show you how many labels are there in each. So it's just showing how many labels are 1. So that's why the sum is being used. If you remove this, you can see we are just filtering all the labels alone. So we can have the sum, and let's take the next one. Row sums equals df of ilog. Again, I will take all the rows and take only the labels, and here sum axis equals 1. So before I'm just taking sum in row wise. Now I am just taking the sum in column wise. Column wise means we are just adding all these things and get a total. In that way we will know whether that particular comment has some label or not. So this will result like this. You can see the row number and the label. Currently most of them are 0, but don't worry, I will have a separate graph to show how many labels are there. Now let's remove this, and I will have no label count equals 0. I'll also say take only label columns, and then for I comma count in row sums dot items if count equals 0. So when you are iterating this row sums, it will get this index along with the count. So that's why I'm having two variables. We're just considering the count. If count is 0 means no label count, we will increment by 1. Now let's print all the values we got so far. Print total number of articles, total number of comments. That will be len of df. Now print total number of comments without labels, which is no label count. Okay, no label count. After that, total labels, total number of actual labels that is present in the whole data set. So that will be x dot sum. So I already showed you how x will be. I will just take it and separate. If you have x dot sum means it will just add everything together, and I will also have this as a separate cell. So the whole purpose of the tutorial for you is to understand what's happening behind each code. Take label columns and sum it column wise. Okay, let's run this. Now you can see this is the total number of comments, and this is the total number of comments without labels, and this is the total number of labels in the data set. So as you can see, around like 1,43,000 does not have any labels at all. So only around 16,000 samples have some labels, and some of them having like multiple labels. That's why we are getting the count around like 35,000. Now let's do some visualization to get a better understanding. Now let's use the same which we done before, or we can just reuse x. Plot dot figure fixed size 8,6, and axis equals SNS dot bar plot, x equals x dot index. As I already showed, the index is the labels, and y equals x dot values alpha equals 0.8, and you can also have colors. So for that you have to specify palette. If you don't specify palette, means it will be very bland, and you just have the blue color. So tab blue, like this. You have to specify different colors for each tab or each label. Orange, tab green, and brown, red, and lastly tab gray. So we defined all the colors. Now let's have the title. Plot dot title, label counts, and plot dot y label count, and plot dot x label equals label, plot dot show. Now you can see all the labels in the chart. I think the chart is very big, and this will also, we will have it as 4. So you can see all the labels and the corresponding count. So toxic having like dominant here, and rest of the labels have a decent count, like obscene and insult having like half the samples of toxic. Severe toxic, threat, and identity hate having less number of samples. So usually if you are dealing with the multi-class classification, means you would do class balancing, but in this case we don't have to do, as each command have more than one label, and we cannot like adjust those labels using this class balancing method. Overall, this is the label distribution. Let's also get a distribution of count of how many labels per command. Like it can have 0, 1, 2, 3, like that. It can have all of them as well. So we can see how it's going to be. Now again, we will use a similar plot. We can just do some few changes. SNS.count plot, and this will have values, and here x I will have df.iloc, and 2 colon, here sum will be access equals 1, or I think we can use row sums. X equals row sums dot values, palette will be the same, and title will be tags per our comment, and here y label will be number of occurrences, and here number of tags. Or we can have labels. So this is suitable. Let's run this. Now you can see the majority of them have no labels at all, and only a few of them having like multiple labels. You can see slowly the labels are decreasing. Now we got the distribution. Next we will go to the data preprocessing, because we have to clean all the comments. I think we already done data preprocessing the start. I think we can remove this. So it's just like a basic preprocessing. So here we will have the data preprocessing. Okay, let's drop the ID column first. df of drop columns equals ID, access equals 1, df head. Now you can see the command text, all the labels. So we just have to pre-process this command text. So for removing stop words, we will create, so stop words equals set of stop words dot words. We are dealing with English language, so English, and I will have a function for removing stop words. Remove stop words. Again, if you are dealing with neural network means we don't have to do this like transformer or LSTM. No stop word text equals for w in text dot split if not w in stop words. We will just keep the w. So what we are doing is we are just checking whether w is not in stop words. If it is not in the stop words means we will add the stop words in the list. So let's say he matches, this is a stop word means it will just ignore that this word and return. We have to combine all the text back from the list. Join no stop word text and then def clean text. So here we have to do converting the text to lowercase, and we have to remove additional new lines, and we have to convert this can to cannot. All these basic pre-processing we have to do. I'm just going to like copy and paste a common snippet which you can find it from the internet. So this is the pre-processing. Here you can just see I'll just converting the text to lowercase and expanding all the text to a proper words. Can't means cannot, nt means not, im means I am. So all these are pre-processed here, and additional pre-processing also has been done. Like if there is additional spaces means we will just have it as like a single space, and we are just stripping the additional spaces from here, and these two snippets will remove all the special characters, and it will just clean the text which we are inputting. After that we will also define stemming. So I will define a stemmer equals snowball stemmer, pass the language which is English. Here also I will create additional function stemming sentence, that is the input. Stemmed sentence equals empty for word in sentence dot split stemmed word equals stemmer dot stem, pass the word, and stemmed sentence plus equals stemmed word, and we can also have the space after that, and then stemmed sentence equals stemmed sentence dot strip, and we will return it. Okay, now we have defined all the functions that is needed. preprocess the comment df of comment text equals df of comment text dot apply. First we are removing the stop words, lambda x, remove stop words of x. Now after this is done, we will clean the text. I'm just doing it line by line. You can also like pass all the function in a like single line, and we will also do the stemming. Okay, now let's display the text. So this will take some time as we have around 1,50,000 samples. So just wait for a while, or in the meantime we will complete the rest of the code. So after this we have to split the input, split input and output, which is x equals df of comment text, y is df of drop. I'm going to drop comment text because the rest of them are the labels. So comment text, I will drop it, access equals 1. After this, split data for training and testing. So xtrain, xtest, ytrain, ytest, train test split, x, y, test split. Okay, let me just complete it and we will get back to that. Test split, I'll just take 20% of the data, and random state equals 42. Now you can see all the text which we done here. So the new lines and the additional special characters were removed. As you can see, the can't is converted to cannot, which is a meaningful word, and all the text has been converted to lowercase. And you can also see some of the words has been stemmed. So here you can see so many stemmed words. This is like remember. So this will just save some of the processing time, or vocabulary will be minimal if you are using stemming. And again, if you are using neural network, means we don't have to do all these things, as it will capture the entire context using embedding. Now let's run these. After this we have to create a pipeline. So def run pipeline. So here we will pass the pipeline, and we have to pass all these split, which we already done. Okay, this is test size. Okay, this is done. And then in run pipeline we will have pipeline.fit xtrain, ytrain, and so this will be train model, predict from model, that will be predictions equals pipeline.predict of xtest. Then I will also get the probability of the prediction. So for that, pipeline.predict, I think it's not suggesting properly, predict proba, which is again xtest. Then print metrics, print ROC AUC. Usually when there is a imbalanced labels like this, we have to consider this ROC AUC score. which will give a clear idea of the prediction and the test distribution. So ROC AUC score of Y test, and we have to pass the probability which we got. Then we will go with accuracy, or we can just have the classification report. So accuracy, I think it won't make that much sense for accuracy because majority of them not having any labels at all. So predictions, and finally I will print the classification report. For the sake, I'll just have lowercase, and then print classification report of Y test and predictions. Target names also we have to give, which I can get it from ytrain dot columns. Okay, now we have defined our pipeline function. Let's initialize those pipelines. First, I will create NB pipeline, which is naive Bayes pipeline of first have a list, and inside that list I will have TF-IDF first. Usually we will pre-process this separately and train the model, but it will take like additional steps, and this is much easier. So TF-IDF vectorizer, consider the stop words, which is English. You can also pass additional parameters if you need. Then I will have NB model, which is one versus rest classifier. Inside it have the multinomial naive Bayes, and inside that I will have njobs equals -1. So this is our first pipeline. Next, logistic regression pipeline. Similarly, we have to do, so I'll just copy and paste it, change this to logistic regression. Okay, I think multinomial doesn't have this parameter. Have to pass this for one versus rest classifier, which have this njobs to use all the cores to train the model. Let's run this. Now let's run the pipeline. Run pipeline of, pass the pipeline, NB pipeline, and pass all the data which we already got. Now this will take some time. In the meantime, we will also pass LR pipeline and run this as well. So here we can see we got ROC AUC score of around 86 and accuracy is around 89, and in the multiple labels the precision is good for toxic, threat, and insult. Obscene is also precision is good. Overall, if you see, the F1 score is pretty poor, some of them having 0. So naive Bayes is not performing well as expected. Now in this case the F1 score is much better, and also in the precision we have all the positive values. Even identity hate is considered in the naive Bayes, in the logistic regression. But here identity hate, this model cannot predict at all, and even severe toxic as well. You can also try random forest or other advanced machine learning models, but it will take a lot of time for training. If you have multiple cores, you can definitely try it. You just have to change this model, and you can just run the pipeline as it is. So we can see the ROC AUC score is also 97 and accuracy is 91, which is pretty good for 1.5 lakhs of samples that we are considering, and also we have like multiple labels which is present. Okay, now that is done. For individual labels or how the distribution of labels that we have in the ROC curve, we have to like plot a graph for that. Let's plot it. Maybe before that we can complete the test prediction. If you want to predict from this pipeline, how we can do that. So test prediction. I will just take a single sample, xtest dot sample of 1 dot values of 0. So this will just give you the full text. I can just pass the text as it is. You can also type the text if you want. So here I don't see that much of a negative comments. I just need a very negative comment to check the model, how it is like identifying the labels. I'm just trying. Last time I got the result very quickly. So here I found like a small comment which is very bad, or it's like a hate speech. So I'm going to use this. So test sentence or sentence, I'll just copy then paste this. So before this we have to do the basic pre-processing which we already done. Stemmed sentence equals stemming of sentence. Why I am adding this is if you want to try your own comment, you can also try that, but you have to do stemming before that. And I will say results equals LR pipeline dot predict stemmed sentence of 0. So it will just have the predictions, and for label comma result in zip of labels. I think we have to define the labels. I will define it here itself. Labels equals ytrain dot columns labels. So this is our labels. Labels comma results, and then print. To print it in a uniform way, you have to use this formatting, percentage 14s space percentage 5s, and then pass both the label and result. Let's run this. Now you can see this is a toxic comment, and this is obscene. So you can clearly see this is a toxic comment. So our model is performing well. You can also try it with a normal sentence. Let's try it. Hello, how are you doing? Now you can see it's just a normal sentence, no negative comment here. So it just prints all of them as 0. So this is how you can do the test predictions. On the final part, I will just add ROC curve. This is completely optional, but this will help you understand how well the model is predicting the label. So we already have the labels. In that case, I'll just have values as well. I just need a list like this. Now def plot ROC curve, test features, and predict probability. False positive rate, true positive rate, thresholds equals ROC curve. So this will give all of these variables. So we have to pass the test features and prediction probabilities, and we will plot false positive rate and true positive rate, and we have to set the x-axis limit, which is 0.0 comma 1.0. so it will have the limit from 0 to 1. We have to do the same for y-axis. Y, let's have a title ROC curve and plot dot x label false positive rate and plot dot y label true positive rate, plot dot grid, which is true, and plot dot legend, and we can just pass the labels so it will have like different colors, and then def plot pipeline ROC curve. Here we just have to like pass the pipeline, xtrain, xtest, ytrain, and ytest. Okay, now label in labels, pipeline dot fit xtrain comma ytrain of label. What we are doing is we are just keeping the comments as it is and training the model with only one label as output. So that's how we can plot this ROC curve, and we will get the predict probs pipeline dot predict prob of xtest, and we will get the first index, which is the positive label. Sorry, this is comma 1, and we will plot ROC curve, pass the y label. I think this we can just say test labels, so it will be y test of that particular label and the prediction from the model, predict props. Okay, now let's plot this. I'll just copy it from the above. Paste it here. Let's run this. This will also take some time. It will just train the model each time with labels separately, and it will plot the ROC curve for each label, how well the model is predicting for each label for the comment. Okay, now we got the ROC curve. Here you can see for toxic, I think we have so many labels. Until 0.8 it was good, but slowly it's the false positive rate is also coming, and for threat also you can clearly see how it is changing. So this is the distribution of ROC curve. If you want to further do some analysis on the results for a specific model, means you can use this, and it will be very helpful for even multi-class problems or binary classification problems. So that's pretty much it, guys. In this video we have seen a lot, but the pre-processing steps are same. Only change is this pipeline and the one versus rest classifier, which will predict multiple labels, and pretty much the rest of the things are same. You can also play around with the model and see how well it is predicting, but overall when I tested it was predicting well. Other than that, if you have any queries regarding this video, please leave a comment below. If you like this video, hit the like button, and I'll see you guys in the next video.